How do I do that? Well, do I know how to solve that problem right there? Yeah. What do I know? I know that the three angles of a triangle have to equal 180 degrees. So 180 is equal to 62 plus 58, right, plus something. Let's just call it x for the moment. Okay, so this is 180 is equal to 120 plus x. That means that x is equal to 60. Okay, so I'm going to put this in here. So I've solved that. Now what? Well, do I know how to solve this? What is this angle here? Well, that's going to be 135 because I just have to add the 60 and the 75. Now what? Well, do I know how to find this angle right here? Yeah, this angle right here, which is 135, and this angle right here, those are a linear pair. They have to equal 180, which means this one has to be 45 degrees. This is working out okay. Now what? I have to find that? Well, that's not enough information. Ah, but that is. If these two added together are 60, and the three of them have to add up to 180, this has to be 120 degrees. Okay? The secret of doing this problem is not getting freaked out, but instead breaking it down to its simplest, just what is a problem here I can solve? Where are the blank spaces I could fill in? What do I need in order to get this? Well, looking at this, if I look at it this way, when I didn't know what this number was, in order to get this, I needed to know what this was. In order to get this, right, I needed to know what this was. And in order to get this, I needed to know what this was. So, you start over here. Add these two together and this to get 180. Find out what that is. Add it to that to get 135 to find out what this is. Use this and this to find out what that is. Okay. Here's a similar problem here. These are alternate interior angles here and here, but they're not equal, which means these two lines here, this one and this one, they're not parallel. So I can't just look at this and say 25, oh, that must be 25 too. That would be too easy. I mean, it would not be too easy. It'd be nice, but I can't do it. The only thing I know here for sure is that whatever this is the same because they're vertical angles. So for the moment, let's just give the x, and let's make this be x. Okay? So I know that 25 plus 66 plus x is equal to 180 degrees. And that means that 91 plus x is equal to 180 degrees. And that means that x is equal to 89 degrees. Now, if I know that, then I know that, which means that 89 degrees plus 54 degrees plus whatever this is equal to 180, which means 143 degrees plus whatever this is equal to 180, which means this thing here has to be equal to 37 degrees. Again, what did I know? What did I not know? I couldn't figure this out because I didn't know what this was. But I knew that this was the same as that, and I could find out what this was because I had the other two angles. So you start with a smaller problem, I can find that. And you say, oh, wait, those two must be the same. Oh, then I can find that. That is the secret to solving math problems, and that actually is the transferable skill, because for the most part, if you can break a problem down, even if it's not a math problem, break it down to the stuff you do know how to solve, instead of trying to solve it all at once or to try to wrap your brain around the whole problem, break it into smaller problems. Solve the smaller things that you can solve and see if the pieces that you find fit the puzzle so that you can solve the bigger problem. Okay, let's see. Find the measure of angle A. Where is angle A? Ah, this is angle A over here. The measure of angle A is 5x, but I don't know what x is. But I do know that if I add these three angles together, it'll be 180 degrees. So 180 degrees is equal to 5x plus 4x plus 135. Subtracting 135 from both sides gives me 45 degrees here. And adding these two together gives me 9x. And that means that x is equal to 5. But they don't ask me what x is, right? And the trick to this one is being able to read the directions. What they ask here is, what is angle A? And the answer is 5 times 5. So the measure of angle A is equal to 25. Okay, moving along. Here's problem number 23. What do I need to know? Angle A right here. Right? Like before, I need to find the measure of what? I need to find x. Over here, I knew what this angle was. I don't know what this angle is, except that these two are vertical angles, so this also has to be 120 degrees. And now I know that 180 degrees, which is these three angles added together, is equal to 120 plus 2x plus 4x. Subtracting 120 from both sides, I get 60 degrees. Adding these together, I get 6x. That makes x equal to 10. And what does that mean? Where's angle A? Angle A is over here. 4 times 10. The measure of angle A is 40. Okay, that's number 23. Let's keep going, see what happens here. Find the measure of each angle indicated. Well, let's see. Again, how am I going to get this? Well, it's inside a triangle. I have one of the angles, but I don't have the other one. But I can find it out because this right here is a linear pair, which makes this 100 degrees because they have to add up to 180. Okay. So now 100 plus 50 plus this is 180. That means this here, the measure of angle F, has to be 30 degrees. Because if this is 30, 30 plus 50 is 80. 80 plus 100 is 180. This one, there are a couple of ways to do this. Right? I could do this the way I did this one. But there's actually another way to do this. You notice I did this in 2 steps. Did this as a linear pair, and then did this. But in the end, doing that, I found out that this was 30, this was 50, and if I just added those two together, it equaled 80. I didn't actually have to go through the extra steps. That's actually called, and we proved this once in class, I think, the exterior angle theorem, which says that the exterior angle, actually the measure of the exterior angle of a triangle is equal to the sum of the measures of the two remote angles. So now you got to wonder, what is a remote angle? Okay, so here is the exterior angle of this triangle. This angle is not remote. This is actually adjacent. The remote angles are the other two. So this says if I add this plus this, it'll equal this. Right? These two added together will equal that. The measure of the exterior angle is equal to the measure of the remote angles added together. Okay. So what added to 57 will give me 97? 40 degrees. All right. Solve for x and justify your answer with either a full sentence or the name of a postulate or theorem. Well, here's the deal with this. These are same side interior angles, so we have the same. Oh, by the way, let me point out, I know that these are parallel lines. So same side interior angle postulate says that if the two lines are parallel, then the same side interior angles are supplementary. What does that mean? It means that if I add x plus 77 to x plus 117, it has to equal 180. So I have 2x here. I add them together, and if I add those together, I get 194. That's equal to 180. If I subtract 194 from both sides, I get 2x is equal to negative 14. And that means x is equal to negative 7. Now, did it ask me for an angle measurement, or did it? No, it said solve for x. So I did. And I justified my answer with the name of a postulate. Okay, and you need both to get credit for this answer. Over here, what do I have? I have two parallel lines. And because I have two parallel lines, I know that the corresponding angles are congruent because of the corresponding angle theorem. Okay? And that means that 130 is equal to 13x, and that means x is equal to 10. That's the answer to that. All right, let's see, 28. Okay, again, I got two lines that are parallel, but I don't actually have things going on at two different intersections. This is all at one intersection, so this actually doesn't matter to me at all. These are a linear pair. And a linear pair are always supplementary. So that means that 8x minus 5 plus 105 is equal to 180, which means 8x plus 100 is equal to 180. What I did there was I took the minus 5 and the 105 and added them together. And that means that 8x is equal to 80, and that means that x is equal to 10. Right. Just double checking here, 8 times 10 is 80, minus 5 is 75, and 75 plus 105 is 180, So that works out. All right. Here, what have I got? I've got parallel lines. I've got alternate interior angles. This is the alternate interior angle theorem, which says that these are alternate interior angles. These lines are parallel. These have to be equal. 95 is equal to 7 plus 11x. If I subtract 95 minus 7, I get 88 is equal to 11x. X equals 8. There we go. All right. Oh, it's another one of those, isn't it? I don't really need this. I only have things at one intersection. These are vertical angles. They have to be congruent. 8x plus 13, let me write that in here, vertical angles. 8x plus 13 plus 9x plus 4 is equal to, actually, it's not that they're plus, they have to equal each other, don't they? Right? This angle has to equal that angle. So this has to equal that. If I subtract 4 from both sides, I get 8x is plus 9 is equal to 9x. If I subtract 8x from both sides, I get 9 is equal to x. And I'm done. And over here, this again, these are same side interior angles. And I know that the lines are parallel, so the same side interior angle postulate works for me here. And that says that same side interior angles, if you take their measures and add them up, they're going to equal 180 degrees because they have to be supplementary. Let's see what happens. All right, I'm going to subtract 55 from both sides. That's going to give me 125. And then I'm going to subtract 133 from both sides, and that's going to give me -8. All right. I'm going quickly because I'm figuring